Reactions of fatty acid like hydrolysis, hydrogenation, saponification, and density of oils and dry oils. Definitions. First, lipids. Lipids is a triester of long chain of fatty acids with glycerol. Next, fat. Fat is a triester of long chain of saturated fatty acid with glycerol, for example, wood fat. Oil is a triester of long chain of unsaturated fatty acid with glycerol, for example, olive oil. Fat and oils are able to saponify, but steroids are not. Fatty acid is a long chain of carboxylic acids, and there are two types: saturated fatty acid and unsaturated fatty acid. Saturated fatty acid contain carbon-carbon single bond in side chain of carboxylic acid, for example, stearic acid. Next, unsaturated fatty acid, they contain one or more carbon-carbon double bond in side chain of carboxylic acid, for example, oleic acid. Saponification process, in which fat or oils are able to form salt or soap with alkali, for example, sodium hydroxide and potassium hydroxide. Next, densification. It is of two types: oxidative and hydrolytic density. Oxidative and hydrolytic product reduces obnoxious odor and flavor. Next, hydrolysis. It causes breaking of triester with water to form fatty acid and glycerol. Next, hydrogenation. Addition of hydrogen to oil in the presence of reducing agent to form fat is a hydrogenation process. Next, wax. Esters of fatty acid with high molecular weight, monohydric alcohol, is known as wax. Next, functions of lipid or fat or oil. They are storage form of energy. They are important dietary component because of their high energy values, and are also because of fat soluble vitamins and the essential fatty acid contained fat of natural foods. They are structural component of biomembranes. They provide shape and contour to the body. They are act as metabolic regulators. Combination of lipid and protein, that is lipoproteins, are important cellular constituent. They are occurring both in the cell membrane and in the mitochondria, and serving also as the mean of transporting lipids in the blood. Non-polar lipids act as electrical insulators, allowing rapid propagation of depolarization waves along myelinated nerves. They also serve as thermal insulator in the subcutaneous tissues and around certain organs. Next, biological importance of fatty acid. Fatty acids are the building block of dietary fat. The human body stores such fat in the form of triglyceride. Fatty acids are also required for the formation of membrane lipids such as phospholipid and glycolipids. They act as fuel molecules and are oxidized to produce energy. They are required for the esterification of cholesterol to form cholesterol esters. Next, saturated fatty acid. Major saturated fatty acid and their sources. First, there are some examples of fatty acid with their structure and sources from which they are obtained. Like first, butyric acid. Formula of butyric acid is CH3CH2 whole by COH, and its source is butter. Next, caproic acid. Formula of caproic acid is CH3CH2 whole 4 COH, and sources are like butter, palm oil, and coconut oil. Next, caprylic acid. Its formula is CH3CH2 whole 6 COH, and sources are palm oil, coconut oil. Next, lauric acid. CH3CH2 whole 10 COH. Sources are plants of lauraceae, coconut oil, palm oil. Next, mylistic acid. CH3CH2 whole 12 COH. Fat of maize, butter, and coconut oil are the sources of mylistic acid. Next, palmitic acid. Sources for palmitic acids are plant oil, palm oil, and peanut oil. And for stearic acid, plant and animals oil. The formula for palmitic acid is CH3CH2 whole 14 COH, and stearic acid is CH3CH2 whole 16 COH. Next, unsaturated fatty acid. There are some examples of unsaturated fatty acid with their structures and sources. Palmitoleic acid Its formula is CH3 CH2 whole 5 CH double bond CH CH2 whole 7 COH, and its source is sardine oil. Next, oleic acid. Sources for oleic acid are olive oil, peanut oil, and linseed oil. Sources for linoleic acid are olive oil, peanut oil, linseed oil, soybean oil. Next, gamma linolenic acid. Source for gamma linolenic acid is linseed oil. Next, arachidonic acid. Source for arachidonic acid is peanut oil. Next, essential fatty acid. Polyunsaturated fatty acids such as linoleic acid and linolenic acids are essential for normal life functions. They are therefore characterized as essential fatty acid. Arachidonic acid is considered as semi-essential fatty acid since it can be synthesized from linoleic acid. Next, physical properties of fat and oil. First, it is colorless, odorless, and tasteless. It is insoluble in water. Its specific gravity is less than 1, and consequently all fat float in water. Oils are liquid at 20 degrees centigrade temperature and they contain higher proportion of unsaturated fatty acid. Fats are solid at room temperature and contain saturated long-chain fatty acid. Triglycerides are the storage form of energy in adipose tissues. Next, reactions of fat or oil. First, hydrolysis. In this process, triglycerides are easily hydrolyzed by the enzyme lipase, which is a catalyst, in digestive tract of animals to give fatty acid and glycerol. The fatty acids so produced play an important role in metabolic process in the animal body. In this process, a compound fatty acid hydrolyzed to form glycerol and 3 molecules of fatty acid. Next, saponification. When triglycerides are hydrolyzed or saponified by alkalis, glycerol plus the salt of fatty acid are produced. Generally, the sodium or potassium salts are obtained, which are termed as soap. In this process, triglyceride react with 3 molecules of sodium hydroxide to form glycerol, and it also gives 3 molecules of sodium salt of fatty acid, which is known as soap. Next, hydrogenation. Unsaturated glyceride react with hydrogen in the presence of a metal catalyst like nickel to give saturated glyceride. This reaction is similar to the catalytic hydrogenation of alkenes. Here the hydrogenation process saturates the double bond present in the fatty acid component of glyceride, thereby converting them to saturated and acid components. The result in the transformation of a liquid glyceride. In this reaction, glyceride triolate, which is an oil, hydrolyzed in the presence of nickel by heating to give glyceride tristearate, which is a fat. Next, halogenation. Degree of unsaturation is determined by this halogenation, for example, iodine value. In this process, linoleic acid, which is a fat, undergoes iodination, or it reacts with 2 molecules of iodine to form stearate tetraiodinate. Drying of oil. The methylene group flanked by doubly bonded carbon atom present in highly unsaturated glycerides are very reactive. Linseed oil, the most widely used drying oil, contains about 63% of its fatty acid as linoleic. The CH2 group present in linoleic acid, as you can see in first structure CH2, that is active methylene group, when attacked by oxygen from air, the hydroperoxy group, that is OOH group, will attach to the same active methylene group and it will form hydroperoxide or a peroxide bridge. Then this hydroperoxide undergoes polymerization to give cross-linked unit in a polymerized triangle. And such a network form a dry, tough and durable film when exposed to heat. Next, density. The term density is applied to any fat or oil that develop a disaggregable order when left exposed to warm, moisture for any length of time. Density is by hydrolysis of ester rings and oxidation of double bonds of the triglyceride. The lower molecular weight acids that are produced are volatile and impart an offensive order to fat or oil. Density is of two types, hydrolytic density and oxidative density. First, hydrolytic density. In this process, triglyceride undergoes hydrolysis in the presence of lipase enzyme to form glycerol and 3 molecules of free fatty acid. Next, oxidative density, which is also known as lipid peroxidation. In this process, unsaturated lipids undergoes oxidation process to form lipid radicals. This is initiation process. Then it undergoes oxidation to form lipid peroxy radical. It will react with fatty acid molecule to finally yields lipid peroxide. Reaction between lipid peroxy radical and free fatty acid also undergoes propagation process to yield lipid radicals, which again undergoes oxidation process to give lipid peroxy radicals. Next, harmful effects of lipid peroxidations like damage to cell membrane, cardiovascular disease, joint disease, aging and cancer. Prevention of density. There are some ways which are used to prevent density, like by using inert gas in packaging, by using antioxidant like ACAD, by refrigeration or by storing in a dark place or by vacuum packaging.